I'm Lukas, welcome to my channel. Today I want to show you an update on my new robot project that I just set up, so let's jump into it. So here you can see a speed test from the robot just after setting it up. And the robot does, after some measurements, a speed of 0.15 meters per second, which is 0.5 kilometers per hour or 0.3 miles per hour. So here you can see another run. Now here you can see a little payload test. The robot itself weighs about 2.4 kilogram or 4.8 pounds. The weight is about 1 kilogram, so it's 2 pounds. So 1 kilogram is no problem. So I added a second just for testing. And it's working. So here you can see a little movement test, which is hand controlled via a PS4 controller, which shows moving forward and moving backwards. Then turn or jaw to the right. Then stepping to the left or moving sideways to the left, then in the opposite direction. Now moving the body up and down. Then roll the body. Then leaning backwards and forwards and to the sides. And then we will do a little jump at the end, which is not very high. So here you can see the robot from above and a little bit closer. The robot is made of 12 servo motors for the legs. The legs are 3D printed and the robot is controlled per Raspberry Pi 4GB version. The Raspberry sends a signal over to a PCB board, which gives a PWM output to every servo motor to control the movements. For power supply I have two step-down bucket converters to power the servo motors, and that's about it. The measurements of the robot are about 45 centimeters in length and about 20 centimeters in width. The standing height varies from 10 to 18 centimeters, and that's about it. So here you can see a list of the components that I used to build a robot. At first, a Raspberry Pi, in my case a 4GB version, it's about €60. Then the two bucket converters to convert the voltage down, I used a battery with 11 volt or a 3S battery and converted the voltage down to 7.2 volt just to give a consistent voltage level and don't have decreasing power by a decreasing voltage level when you use 2S battery. Then the 12 servos, I used 35 kilogram servos. You need 12 of them, they're about 35 euros each. Then a battery, as I mentioned, I used a 3S battery with about 5000 milliamp hours. Then several power bank to power the Raspberry. Then USB to USB-C cable from the power bank to the Raspberry to power it. Then the power cables, which I don't mention the price because I had someone around. Then the PCB board to control the servo motors. Then a battery charger to charge the battery. Then a part for building the body. The PLA for doing the 3D prints. I used half a kilogram, which is then about 10 euros. And in the end, some screws. So all in all, the costs were about 580 euros or 680 US dollars. So if you come so far, please consider to give me a like and to subscribe to my channel. It's free and you won't regret it. So you may ask yourself what's next. And first of all, I want to give the robot the ability to manipulate stuff and to carry stuff around. And for that I have designed a bigger servo motor or a gearbox with a little BLDC motor and a potentiometer for controlling the angle of rotation. So I can give the robot an arm to manipulate stuff. And after that I want to use my stereo camera setup to give the robot the ability to map its surroundings and to navigate autonomous. And after that I want to do some machine learning on it, and that's what I'm going for with my robot project. So thanks for watching.